is for the whole set. So in actual sense, this is what we are going to do. Sorry for that. This is what we are going to do. Biology is what? 23. Then chemistry, 32. That is the idea there. So we can't say this number is for here, it's for the whole party. Okay. Then X peoples, they study what? Both. Take note now here, both. X, they study both. According to the notes that I talked about there, where are we going to put the both?
Where A and B are intersecting.
Where
In
B
between.
and C are intersecting in between. So meaning to say, the X that we are given there is for this part here, for the intersection. Okay. Now let's correct ourselves on that part of biology there, because they gave us everything for biology. What is presenting this part here is 23. So if 23 is the whole of this set here, if this set carries 23, this one, what about biology only, this part that is remaining? Okay, let's say here, let's say in between here, there are 6 students there. Or there are 6 people there. How many people are we going to remain with here on biology only?
23 minus 6.
23 minus 6. All right. But this time we do not have 6. We've got X there. So
23
if these
minus
ones, so it's going to be what? 23 minus 6. Are we seeing the idea there?
Yes, sir.
Yes.
So this will be 23 minus X. The same thing that you are having here. If this is 32, then the whole of this part is actually 32, the whole of this part. Are we seeing that X is part of the 32? X is part of these 32 elements. So we have to subtract this X from the 32 so that we remain with what here? Chemistry only. So this part here is for chemistry only. That's chemistry only. No problem. Let's move on to the other part. 5 people, they study neither biology nor chemistry. They study neither of these subjects. All right, paper 1, we understand this mostly because we have got these words, actually, these words. Neither, no. You'll be given this statement, neither mathematical tables nor calculators may be used in this paper. Once the word neither is used, it means not part of. So if they say neither, but at the end they say is used, meaning to say that part is not supposed to be there, is not supposed to be used. So if we are saying neither biology nor chemistry, these 5, they do not study. Are you seeing the statement there?
Yes.
5 people, the part is that they study. But what are they studying? Neither. They are not studying anything. So in actual sense, instead of them giving us a proper statement that 5 do not, it was supposed to be like this in actual sense. 5 do not study any of the 2 subjects. That was supposed to be the statement. But look how they want to make this statement something else. 5, they do not study any, but they are saying 5 people study. But you find out they don't study anything. So that's why the word neither is used there. So where are we going to have these 5 which do not study any of these 2 subjects? Where are we going to have these ones? We're going to have it where?
In the
Out.
mother said.
So we are going to have it outside of what the B and C in the mother set, which is our universal set. So that is where the 5 elements are. So take note, these 32 is 23, 32, these numbers are not to be used. It is just something that was helping us to indicate, to say that these elements all here, they're 32. So on your calculations, you do not consider that. All right, now that we have filled in these values or completed our Venn diagram, we've actually answered this question here, which was to complete the Venn diagram by filling in the number of peoples in each region. So we have each region, biology only, both biology and chemistry, chemistry only, those who do not study any of the 2 subjects. That is the idea there. Then from there, find X, the number of people who study both biology and chemistry. So how are we going to determine the value of X, which is
I think
both?
we have.
Yes.
I think we have to make an equation.
We have to make
Equation.
an equation from where?
From 23 minus x and 32 minus x is equal to 46.
Is equal to 46. This one and this one.
Yes.
Okay. Any idea? Any other idea? All right. We can't equate only these 2 to 46. 46 represents what?
All students.
Class. All
Okay.
students. All students. So if we take this part and this part, what about these ones? What about these ones? So meaning to say, to formulate an equation, you must equate everything. Zvese zvatiri kuona padiagram redu. Everything that we are seeing there. All right. So what does it mean? We are going to have our elements or the numbers according to the class of 46 learners or 46 peoples. We've got those ones for biology only, how many? 23 minus. So it's now an equation. All right, I just hope it's going to be clear if I write it here. So it is going to be 23 minus x plus this x plus 32 minus x plus the 5. So everything must add up to what? To 46. So that is how you formulate an equation there. You add everything. The universal set is a set of 46 people. But 46 people is this set, everything there. This is your universal set. So this is your class. All right. So anyways, let us add the numbers together. 23 plus 32 plus 5. What are you going to have on the left-hand side? 23 plus 32 plus 5.
60.
16.
Yeah.
All right. Then we move on to the part of x. There we have got minus x plus x. They cancel. You remain with what? Minus x. So this is equal to 46. So minus x is equal to what? 60 on the other side. That's a minus. 46 minus 60. What are you going to have?
Minus 14.
Minus 14.
Yes.
So therefore, at the end, x is going to be what? If minus x is equal to minus 14, x is going to be a positive 14. We divide by what? By negative, by negative. So thus, the number x represents what? The number of people who study what? Both. Both. Chemistry and biology, or biology and chemistry. So the question can be, after you have calculated the value of x, you'll be asked like, how many people study biology only? There we need the numerical value of the number of people, the people who study biology only. So how many?
23
Yes,
minus 14.
so it is going to be 23 minus the x that we calculated, and our x is what? Is 14. The same thing if you were asked about those ones who study chemistry only, that will be 32 minus x. Are we together?
Yes.
So this is the idea of the word problems. When working with the word problems and you are given what? Two subsets. So the first thing that you need is to write, the first thing that you need there is to present properly on the Venn diagram the information that you are given, depending with the question that you have. Sometimes you are given, what can I say? Sometimes you might be given like the diagram already. They might draw the diagram for you. It will be an advantage if it is like that. It will be an advantage. But if the diagram is not drawn, that means one, you have to present your diagram. what are you given on your diagram there is important. So like I presented before, that these two sets that we are having here, when the rectangle is presented, whenever you present this rectangle, this one, it is because there are elements which are not part of the two sets. If we have got elements that are not in A, and also they are not in B, on that condition, we can present what? With that rectangle. But if like, let's say all the students in this class they study at least one of the subjects. All right, let's say we've got mathematics and history. All right, at least we have this subject. Anyways, it's fine. If we have got a condition that the learners in this class, they study at least one of the subject. At least one of the subjects. Okay, what is the idea there? You're given two subjects, but the condition is that the learner study at least one. This is a condition. It's like this: when you enter this class of these people that we are given there, and you ask the learners that are in the class, like they're learners there, you just randomly select a learner or a student, and you ask the learner, which of the subjects are you studying? Then the learner answers none. I want you to be careful there. The learner is answering none of the two. Is it possible for a learner to give us such an answer when this is given this way? At least one of the subjects. But you ask a learner, and the learner is answering, I study none. Meaning to say, I'm not doing mathematics, I'm not doing history. Is it possible? No, it's just a question. Hello, are we together?
It's not possible.
All right.
What is the learner doing in school in the first place if he's not studying?
What is what?
What will be the learner doing at school if the learner is not studying any of the subject?
Oh, it's about being at school. All right.
Yes.
Sorry, I also think the word at least is suggestive amongst the two pane one childhood.
Andiga, no. Guys, the last question at answer, the last question that we answered, were we not having 5 who were not doing, we're studying none, neither, no. On our last question. They were there, isn't it? But they were not studied. So it can be like that. I can be at a certain school, but when the statistics is being picked, or well, that part of a survey being conducted, it's conducted on the subject that I'm not studying, but I am at the school. Are we understanding that? So it can be, so it's not about that. It's about being, it's about the survey conducted on what you are doing. That is the case. So you can be at a specific college, school, whatever, but not doing that subject that they are conducting a survey on that particular moment. But on in a class now, like this one, in a class, this one, they are saying the learner studies at least. So the guarantee that we are having now for that question that I was asking is here, at least. At least means you are doing you are doing something between these two subjects. It's either you're doing maths or you're doing history, or you're having both subjects at the same time. Not to say you do not study, but that question, the previous one, there were 5 who studied none of the subject. They were not doing anything. But in this case, we cannot have that. So whenever you have this condition, it means now it's not necessary for us to have this rectangle here, because there are no elements to be outside of what? Of these two sets. Maybe this is your maths, this is hapana ma-elements atichawana kunze kuno kazviti, because hakuna munhu asina chaari kuita. At least you are doing something. So meaning to say at the end, everything is going to be filled in within this set. So meaning to say M union H is equal to the number of learners or the number of students in the class. That will be the idea now when it is like this, when there is at least. If you combine these two, these are the learners inside the class. But on that question, where were those ones who studied none, were to combine what is in this, what is in this, and what is also outside of the set to give us what is inside of the class. So in order for you to have what is inside of the class, you're going to take these together. You also take what is outside. But in this case, there's nothing outside. So it means the combination of M and H combined together like this. These are the number of students in the class. Are we together?
Yes.
So it is very, very important, very, very important that you realize that, you figure out that at least. So when answering sets, the most part there is the most affecting part is on that part that that I'm talking about. If you don't consider those statements, at least this and that, you end up answering the way that you're supposed to be actually answering another question, not the one that you're answering. So meaning to say, it is very, very important that you do not that. All right, I want us to just check 1 or 2 questions here. There's this question here. Let's hope it is going to be clear so that we can figure out how we're supposed to attempt some of these typical questions where this part is involved of where this language here is involved. So it's not like always where we are going to see this, but whenever it is being used, try by all means to apply it properly. So let us check this question here. It's an advantage already. Everything was presented on this type of a question here, but it's just something weird that is happening that I want us to check here. We are given the Venn diagram shows the universal set. So in most cases, this we do not also read this information. Read your information. So there you are given the universal set. The Venn diagram shows the universal set, and this universal set with the subsets A and B. The numbers of elements in each region are expressed in terms of X. The numbers of elements, meaning to say X, it's something that represents a certain number, just like 2, 3, whatever that we have. All right. Write an expression in terms of X for the number of elements in A union B. A union B. A union B, batanidzo 1 wa A na B, batanidza A na B pamwe chete. That is A union B. We combine these together. So meaning to say, if we were to combine A union B, what are you going to have? And this is supposed to be in terms of X. So the number of elements in A union B is going to be equal to what? Meaning to say you combine everything that we are seeing. That is X squared plus, we have got 12 minus X, and here we've got what? 16 plus X. Just like here, maybe there are 3 elements. Here there are 5 elements. Here there are 2 elements. How are you going to combine? You're going to add 3 plus 5 plus 2. But here we are given in terms of what? In terms of X. So we're going to add in terms of X. So that is the idea there. So we are now having X squared minus X plus X. Minus X plus X. That's what? That's a 0. This one cancels. 16 plus 12 plus 16.
28.
We're going to have 28. Okay. So this is our expression in terms of what? In terms of X for A union B. Then B, given that the number of elements, N represents what? Number of elements. So we are now told that the number of elements in the what? In the universal set, everything that we have in the universal set is equal to what? To 40. Okay, then just check the sign properly here for that universal set. So everything in the universal set is equal to 40. And what is it that you're talking about the universal set? It is this part of A union B and also the 4x, which is outside. Are we seeing that 4x is supposed to be considered now? This one. When we combined A union B, this one, 4x was not there. So meaning to say we are supposed to just add from this one already. This is A union B. We combined this A union B together. We got X squared plus 28. So meaning to say, if we add this 4x, which is outside of A union B, this part here, which is out of the sets, What are we supposed to have at the end? We are supposed to have the total of 40. We are supposed to have the total, which is the number of elements in the universal set. So the question is, show that, form an equation and show that it reduces to this equation. So how can we show that it is going to reduce to that? What are we going to do? So to show that, guys, what can we do? We can transpose the 40 to this other side of the equation. So are we seeing that the highest power there is 2? So if the highest power is 2, what else are we expecting here? A quadratic equation. Ax squared plus bx plus c is equal to 0. One of the sides of the given equation must be equal to 0. So by transposing this, I'm going to have x squared plus this 4x here. Then transposing the 48, this side is going to be, the 40 is going to be 28 minus 40. 28 minus 40, what are you going to have at the end?
12.
28 minus 40 is 12.
Minus 12.
Minus 12. All right. So this is exactly what we are having there. So that is to show that.
Okay.
So are we seeing the set part is on this one? This is the set part. Number of elements is 40. That is where the set is playing a role. The rest is no longer about the set. It's now about you and your normal equations. That's a quadratic equation there. We now have a quadratic equation. So this is now C item 1, solve the equation. Which means after having this quadratic equation, now we are supposed to solve. How do you solve this? This is no longer about sets. This is no longer about sets. We are now back to normal equations. How do you solve this quadratic equation? By factorization. This is paper 1, so you can just apply your factorization. The coefficient of x squared here is a 1. So remember your factorization, to have x squared, we must have x and also x here. So you are going to need factors of the constant. And what is our constant? Minus 12. And these factors must add up to what? Positive 4. So do you have two numbers? These two terms, these two numbers, multiply these two numbers, you obtain a negative 12. But if you add the numbers, you must obtain a positive 4. That means we've got what? 6 and minus 2. Is that so? Obtain a negative. Is that so?
Yes.
All right. So meaning to say, with these terms, with these numbers, plus 6 minus 2, they must be equal to 0. So one of the brackets, if it is equal to 0, it means x will be what? Plus 6 on that side, it will be a minus 6, plus 2 on the other side, it will be, minus 2 on the other side, it will be a plus 2. So that is the values of x. So when you are solving the equation, like this question is just solve the equation, just solve for x, leave it like that. But in the normal sense, can this x be a negative 6? Can x be a negative 6? Is it possible that x can be a negative 6 here? We put a -6 here. 4 times -6, it means that's a negative there. Here it can be 12 minus, it's going to be a positive. Here it's going to be a positive. -6 squared is going to be a positive. But on this one, if we plug in the -6 here, it means we've got -24. Is it possible that the number of elements they can be negative? Is it possible? Talk of maybe these are students. These are learners in a class. Can we say I've got -24 learners? It's impossible. So in our calculations, it means -6, we are not going to use it in our calculations, this one. But as for the solutions that you are being asked for the values of x, leave it like that. These are the values of x. But when calculating anything that where we need to use the value of x, like this part where we are now given hence it's a continuation from what you just determined. Find the number of elements in A complement intersection B. So the first thing is to locate this region. We need to locate this region of A complement intersection B. We need to locate that part. So where are we having A complement intersection B? What does it mean? A complement intersection B. Which part here on our diagram represents A complement intersection B? Is it the 12 minus x? Is it the 16 plus x? Is it the x squared? Is it the 4 minus x? Which region represents A complement minus A complement intersection B? All right, no problem. Let's do it this way. Whenever you want to figure out this, you can go back to the original sense of this diagram here. What does it mean? Like, okay, let's have it like this. Remember, this is your universal set. This is your A, this is your B. All right. If we are to consider A complement, let's start with A complement. A complement, these are the elements which are not in A. Which elements are not in A? This is set A, this one. This is our set A, this one. So what is not in A? What is not in A now? It means these elements, these ones here. They are not in what? They are not in A. Everything that we are seeing here is not in A. Everything that we are seeing here is not in A. But the question is, it must be intersection B. This part that we are saying it's not part of A, the same part, it must be an intersection to B. And what is our set B? This is our set B. All right, let's put it this way. This is our set B, this one. Remember, this is your set B. This whole part here is our set B. No problem, we understand each other. So this is our set B. I'm just going to shade the set B, this one. All right, let's shade. This is where we are having our set B. This is our set B, this one, the one that I just shaded now. So the question is, intersection means what? Intersection. A combination zvatiri kuwana kuna rimwe side uyezve zviri kune rimwe side, like both sides, isn't it? In both cases. So if you are doing this, which part represents an intersection? An intersection is the part where we are having these two, but where we are having like an intersection patiri kuwana zvinhu two zvatapata shedha panhu two. Meaning to say it can't be here, it can't be outside, but the part that we are remaining with that is shaded twice is this region. If we have to check properly, this region here. Aka region aka. Ndo kari kusara kakashedwa twice aka. This one. Are we seeing it? This one. This is the region where we shaded twice, meaning to say it represents those elements which are found at the intersection of the two combinations. Meaning to say, what is not in A, intersection, what is in B is going to be this part. Are we together?
Yes.
The combination there, this part that is the combination of the two. Intersection means both, where we are having both. But if it was A complement union B, what was going to be our answer now if it was like this? Which part were you going to take?
Everything that
question
is in B.
Everything that is what?
In B, including where it meets with A.
Okay, what about this part? We are not going to take it.
Yes.
This one outside.
No, we are not going to take it.
All right, but that is also a complement, isn't it? Meaning to say, when the union is there, we are going to take everything. As long as long you have shaded that, you are going to take it, everything there. Meaning to say, if it was like this, the only part that was going to remain is this part that you did not share, this one. We're going to take everything. Union mubatanidzwa kutora zvese is to combine everything.
Everything that is in B.
Everything that is in these two sets. Union of these two. What
So
is...
say the question remains good. If about union beyond, so zvinhu zviri mumother's set is, how is it part of this? Yet it is not part of B. I'm not understanding.
Exactly my question.
Mother said this part, this one.
Kunzoku.
This one, these ones. All right. When we are saying union, tukudzoka pavara rekuti union. Rekuti chi-union. Mubatanidzwa. Mubatanidzwa wezvese. Saka tiri kubatanidza zvisiri muna A kune zviri muna B. Kubatanidza
ndopone mubvunzo wacho ipapo pakuti zviri mumother set izvo hazvimo muna B ka.
Patruita sei tiri kubatanidza kureva kuti what can we say?
So is it because of kanhu kari pana A kaka complement ako now takutora zvinhu zviri mumother set?
Yes, we are ndinoti tibate vara rekuti union first there. What does it mean? tikabata ipapo zvinobva zvatibatsira. It's like this. Let's take something that is easier to give there as an example. You have nothing. We have nothing. You have a zero in terms of something that we are comparing to with someone who has got 5. Maybe I don't know what you're talking about. Is it sweets or whatever that you have? Then the question is, combine what you do not have to someone with 5 sweets. Meaning to say, we are going to combine our 0 to this 5. We are now having 5. I'm having 2 elements. This one is having 5. Combine what you have to what this one have. Meaning to say, I'm going to have 2 plus 5, which is a 7. So the question here is, combine what is not in A. A complement means what? What is not in A.
So A complement, it means the things that are not in A, but it's in the mother's set.
In the mother's set, that is what A complement means. But combine that to B. So if you combine what is not in A, you combine it with B, what do you have at the end? Kuti uri kubatanidza zvinhu siri muna A, wozvibatanidza wozviunganidza pamwe chete nezviri muna B. Zvichireva kuti chii? Ndo pese patutaura. Ndava zvisimo muna A pane kwazviri kuwanikwa. If it is not in A, it is somewhere. The elements which are not in A are the ones, this one, that I have indicated here in pink, this one. They are not in A. This part that we are seeing here in pink, this one. The set A is the one that, this one in green. This part here that we are seeing, this part is not in A. Are we seeing that elements which are not in A, the ones that we are saying they are in the universal set? Some of these elements, they are also in B. If we are to say it is not in A, it does not mean it is not in B. No. We are talking about A. It's not in A, but it is somewhere. So if it's not part of this set A, this one, because this is our set A, this one. If it's not here, then it means it's outside of A. These are the elements outside. Meaning to say also some of the elements they are in B. B is part of also that mother said this B only, not the whole of B, but the part of B only, because the moment we take this part of B, there's a portion of B that we left out, this one. This part is also part of B, this one. But we can't take this part at this moment, this one. Why? Because A is involved. We are saying it's not in A. But when it comes to this statement, which is saying union B, when we combine with B, this is our set B now. This is our set B, this one. Remember, this is our set B, this one. Up to this point, this is our set B, this one. Even that part that we left out before, it is now involved because of union. Union is to combine. Even if you were at 0, but the moment we combine with someone with something, you are now having that something. So even if it was not part of A, but the moment that B is involved, it means these elements, this one, this piece here, because it is part of B, this one, this circle, this one. So it has taken some elements which are in what? Which are in A. But there are those ones which are remaining. This part is remaining. This one is not going to be touched, this one. There is nothing that is going, but this part of B is going to be taken. Apana B. as long as union B, it means everything in B has to be taken. So at the end, this is the part that we are going to do. We are going to take this part. We are going to take this part. We are also going to take this part when the union is there. I don't know if it is clear. We are combining everything for union. So this is what I want you to note there for union. Whenever you see the union, if you are using this method of shading that I'm using there, as long there is a union, you take everything that you shaded up. Search our shade and be part of your answer. As long there's a what? A union. As long a union is involved, take everything that you have what? Shaded. But for an intersection like that question that we had, which was focusing on the what? Or on the intersection, I ended up saying this is going to be our answer because intersection, we need both. So notice pari kuenda makala 2 up, power shade up, and the papa trukona pani makala 2 pari kusangana. That is the part of intersection. Meaning to say, A, intersection B, we are going to remain with what? This part, but we're going to pakashedwa ka 2 up. No pane both. That part, it represents both. So meaning to say, on our diagram, which part are we talking about? We are talking about this part of 16. Is that so? This part of pakashedwa 2 up. This is the part of what? 16 plus x. So this is the answer that we wanted. A complement intersection B. This is the set that was going to remain. But we need the numerical value. So that is where we are going to use the x, which is a positive there. Remember I said x cannot be negative. We cannot have negative 24 elements. So if taking x being a positive, it means we are going to use x being what? X being a 2. So that will be 16 plus 2, which is 18. All right. That's okay. Per same person irapai. But to want this one like this one, this way. Maybe it can make sense. This is our set A, or B, the universal set. Remember, we wanted to indicate A complement union what? Union B. This is where our question was. Let's say we've got elements here. This is 1, 2, 3, there's a 4, there's a 5, there's a 6. All right, just elements of your choice like this one. Tangopama elements of our choice. We want to see the region. Are we going to have that region that we talked about before? You can present this way. You can even put numbers of your choice. The way that I'm doing like this. You put your numbers of your choice just to figure out, because you want to figure out the region that exactly you want to use. So you just put my numbers like that, 1, 2, and so forth, even my letters. All right. Let's try this by listing out my LA. This is another way that you can note the region canal, which is a problem on that part. A complement. Which elements are of A complement? A. Let us list down my elements as A.
2.
2.
5.
5.
And
6.
6. Then B.
6.
All right, only 6.
3.
In B. Also 3 and 6. We are talking about B, not B only. As long you circle, pana B says it. As long you put a circle in B, what you see is B. So we see 3 and what? 3 and 6. So the question, you still remember that question that was like this, 2, 4, whatever that you're given like this, then intersection B, or it can be union B, where you have to list these elements and you take what is on the intersection. This is the same question. You listed the elements of A complement. These are the elements. Now unite these together. That is the union. So if you combine what, this is not in A, this one. These elements, they are not in A. So if you now combine, union means combine. So if we combine what is not in A to what is in B, what are we going to have at the end?
2.
We are going to have 2, 3,
3,
5, 6.
and 6.
I want us to take every part where these numbers are on the diagram. Okay, where is 2, 5, 2, 5? Are we seeing the outside of these sets? 2 and 5.
Yes.
The outside of these sets, okay? 3, where is 3? 3 is here. Where is 6? 6 is here in this region. So this is the region that we had previously, if you still remember, of A union B. This whole part here. The only part that remained, if you still remember, was this part. So that is the
Sorry
idea.
to take you back. Sorry to take you back a bit. So
Uh-huh.
apart put 3 uyant move some per A complement because 3 also belongs kuna B. Ndipanenge pandijamba ipapo.
Yes, 3 anozova pa-answered because ari muna 3 union kubatanidza kuzvafanira kuti toti alright, zvangufanira zvatambotaura paya kuti wanga usina anything, meaning to say 3 was not there, but because panozonzi combine with someone ane that same number, chatovepo pa combination iyo. So the first thing, it was not there. Truly, it was not there on the A complement. But pakungoti unite, patinongonozvibatanidza chete nezvemuna B, 3 atovepo, even though it was not there. So are we seeing the concept now?
Yeah, thank you. Understood.
So we can present it in terms of numbers, and this beauty, is, or you are going to present it this way. If you present it this way, like this one, if you need A complement union like what we have on this part here, we already shaded A complement and what is in B. So to unite, we take everything as long as shader. Whenever there is a union like this one, you take as long as long it's shaded, that is part of your answer. So every shaded part, as long you see the part that is shaded there, that is your answer. So at the end, our diagram or the part that represents A complement union B was going to be everything that we are seeing on the diagram there, except for what? For this part, Ilipanda A, we're going to take away, even, because they can even ask us to shade this, meaning to say we're going to shade everything there. On the question, where this part here, A only is the one that was not going to be shaded, this part of A only, but everything was going to be there. Because of what? Union anobatanidza zvese, chero zvanga zvisipo. But intersection now, you have to check both. So intersection, you check where these two colors, power shader ka 2, ndo pana intersection. Pega power shader ka 2 ndo pane answer yako. Asi union, pese poita say power shader ngapatoro. Are we together there? So meaning to say this is supposed to be something that we are going to talk about shading, this part of shading our sets. So just because of the disturbance that we had today of our class, I think we are going to end here. Then tomorrow in our next class, we're going to talk about this part of what? Shading. Part and go shade them Venn diagrams. It's another part that they can ask you either to shade a certain region, or they'll give you a certain region that is already shaded, where you are supposed to what? Where you are supposed to give now the presentation of what? The set that presents that region. So please, can we try to do as much questions? All right. So for our revision, I mean for the activity, can we try this question as our activity, this one? Tomorrow, but tomorrow we are going to focus on what? That part of shading. I need to talk about that part. So let's try this question as our activity. June 2015, question number 2A. It's a paper 2 question. It is given that X is an element from 1 to 10, where X is an integer, A prime numbers, B factors of 20. List these. Then at the end, draw a clearly labeled Venn diagram to show these sets and their elements. So be careful on the diagram. Everything you have listed it before, Pana. So list your elements properly. List everything properly so that your Venn diagram is going to be clear also. All right, so like I said, we'll continue that part shader tomorrow. Any questions?
Pane graph draw
All right, so that one I said, all right, we're gonna check it. I think it is that part of distance time graph.
Yes.
All right, so I think let us just